I just take them on like whatever I have here, or is it supposed to be like Etherpad or something?
Yes, you should be able to take them on the directly on the tool. Do you know how to get there?
Um, uh, on the it's in the agenda, right?
Yes. The hmm, where is it? On the upper part in the middle of your screen, you should have the note-taking tool icon next
Yep.
to the right to INTAREA. There you can take.
Okay.
Thank you. Thanks, Josh. Thanks, Bill, for sending the or you have the link there on the chat. Bill just sent it. All right, so we're at time. Thanks everyone for attending the INTAREA meeting. Juan Carlos Zúñiga here with Wasim remote attending. So moving on, as usual, note well, reminder that we are conducting this meeting under the IETF policies. And so also regarding patents and code of conduct. So by participating in this meeting, you agree to the IETF processes and policies. And you need to be aware that your contribution and participation is covered by these policies. So any information that you provide to us will be handled in accordance with the IETF privacy statement, and you agree to respectfully treat other participants in a professional manner. If you have any question, you can refer yourself to those BCPs that are here on the screen. Some other note well points. Uh, so all the information here is recorded. Um, we strive to create and maintain an environment with different backgrounds and in a respectful way. We ask you to treat everyone with dignity, decency, and respect. We should not engage in harassment or any aggressive behavior. And if you believe that you have been harassed or you notice that someone else is being harassed, please uh, address yourself to the ombudsperson. So for in-person participants, please use a QR code or log to the Miteco so that we can record your attendance. As usual, we will be using the queue, the virtual queue for both online and remote attendance. For remote participants, please keep your audio and video off unless you're sharing or presenting. And well, that's it. No, this is a mistake. We should say 119 Brisbane, but the links are correct. And for the agenda today, so we're going to go through the usual chair slides. Then we will have Tommy presenting, communicating provisioning domains, proxy configurations in provisioning domains. We have Bill then presenting the probe, utility probing interfaces, as well as extending ICMP for system identification, and the Savvy solution for wireless LAN by Lynn. Uh, so this is what we have for the agenda. Any bashing or discussion on the agenda? All right. Uh, Hearing none. So we're moving on to quickly to the working group status update. We have two working group items. The first one is the IANA considerations and IETF protocol and documentation usage for IEEE 802 parameters by Don. So this document has been in the RFC editor queue for quite a bit. Um, I don't think that we don't have Eric here, right? Or the other Eric now. it, uh, yeah, so I guess not much we can do there. I don't know if that's the usual wait time for an RFC, but to my understanding, there are no issues. It's just waiting there to be progressed. Okay.
Eric Klein. I haven't been tracking this because I think Eric was the responsible AD for this document. I haven't. Nobody's brought any serious problems to my attention. So 134 days is on the long side, but I don't know what it is might be blocking them. It could be they have another large chunk of documents to process ahead of this one. So
Okay.
But I'll try to look up something right now.
Okay. Thank you. Thanks for that, Eric. The other draft, just as a reminder, this was already discussed and presented in previous meetings, but we have the protocol numbers for SHIC that was moved to the SHIC working group, but still shows in our list. So besides that, no other updates really. Okay, so any questions regarding the working group status, documents, and updates?
I do. So just from the meeting notes. So the first one was IANA considerations for.
IANA considerations is the one that we have on the screen. The first one. IANA considerations and IETF protocol and documentation. That it's been 134 days in the RFC editor queue, but apparently no issue, no specific issue there. It's just an unfortunate delay.
Okay. All right.
Thanks. All right. So, Don.
Yeah, Donnelly's like author of that draft document from.
So could you speak closer?
Donnelly Slick from Future Way, author of that draft. I did actually go by the RFC editor table and spoke with them about this. And I guess it's gotten sort of connected to another draft which references it. But I mean, it's not being held up exactly, but they expect them both to come through at the same time. And it is in RFC editor state, which is the very last state of the editing process. So while they were reluctant to give a precise prediction, it should pop out very soon now.
Okay, thanks a lot, Don, for that update. Then you have it. Okay. Okay. So if there are no more questions, then we can move to the next one, which is Tommy. You want to share from your side? Or? You are here. Thank you. Beautiful. I think you can.
Okay. Hello, everyone. I'm Tommy Pauly from Apple, and I'm presenting this on behalf of myself and my co-author, Dragana from Microsoft. And if you've been at INTAREA for the past couple times, you will recognize this. This should not be new. So apologies for any redundancies, but we do have some updates, and we'd love to see adoption soon based on that. All right, so as a short recap on what the protocol does, this is about using the PVD or provisioning domain JSON format that was defined by INTAREA in RFC 8801 to add support for communicating information about proxies in there. So relatively modest in its scope. And there are a couple different use cases you can have here. You can ask a known proxy that you already have. Josh, you may want to mute your microphone. No worries.
Apologies.
All right. So you can ask a proxy that you already know about to say, do you support other proxy protocols? Effectively, this is an upgrade from something that you may only know as a insecure HTTP Connect proxy or a SOX proxy. and learn that it supports something better like a secure version of HTTP Connect or a mask protocol, etc. You can also ask a proxy that you already know about a configuration that it has to say, are you going to let me talk to all domains or only some domains? And you can also have a mechanism to learn about proxies that are associated with a network, so that when you are learning about a network's provisioning domain, you can understand the associated proxies in a secure manner. So here are just some diagrams of examples. You can have a HTTP proxy say that I support mask. Or you could say that I support only proxying to these internal domains. Or the network can say, hey, I have this proxy that you could use instead of what you would be using otherwise. And that opens up all of these sorts of questions about, do you trust it and do you want to use it? But that is mentioned briefly in the draft. So we had a discussion about this before, and I think we saw good support for moving forward with this overall mechanism. But one of the key pieces of feedback was around the format for how we were communicating proxies being admittedly too naive. Here it was just a list of URLs. Not only does that have implications on being too unclear about what exactly you are supporting by having to infer too much from the URL, but it was also brought up that some use cases, like learning about a proxy for media over quick, may need more extensibility and more ability to communicate what this is for. So we have changed the format in the most recent version of the document to, instead of be a flat array, we essentially have like an array of sub-dictionaries. So you can say, here are my proxies, and then each one is described with its own JSON object, which can have multiple keys. And now we have an explicit protocol field for which proxy protocol is being used for this proxy, and then a proxy key that describes the location of the proxy, which is either a full URL for all of the modern proxy types, or is just kind of the legacy host and port that you would use for old HTTP Connect and SOCKS proxies. So this version of the draft defines some proxy protocol types. These are either essentially legacy types, or they're reusing the HTTP upgrade tokens and protocol pseudo header fields that are used for the modern types of mask. And this is extensible, and you could have a registry and register more protocols in here. There are definitely open issues and things we want to continue working on and having discussions with people who may use this. We need to look at how we correctly handle extensibility of adding new keys into these sub-dictionaries to understand cases where there are essentially mandatory keys and extensions, such that you want to make sure that older implementations, older clients that are learning about this particular proxy don't use this unless they understand the new key, because this is a mock specific proxy and can only be used in this one way, but also be able to have other proxies that could add new keys, but still allow legacy clients to use them in some more generic way. So we need to work on that. There was a discussion about providing hints for what protocols can be used to speak to the proxy. So you may have a proxy URL that indicates that it supports Connect UDP, but maybe you want to provide other hints for, talk to me first over HTTP 3 instead of HTTP 2. Maybe that's just something that becomes an optional key. And we also had a comment asking for support for exclusion domains, of saying you can reach anything over this proxy other than these domains. I think that's a very nice feature that would allow it to have more parity with and ability to replace pack files. And I think there should be some discussion about where exactly that should be. Should that be at the parent PVD level or within a specific proxy subdictionary? But I think these are all things that are worth considering potentially, after an adoption, and have a broader community review of what would be most useful for people to use. I do also want to call out some of the relationship with what I would call legacy proxy discovery mechanisms. And the document does touch on this, how this is related to things like pack files and WPAD, which have been common techniques that have been provisioning proxies for many, many years now. But those don't support modern and secure proxy types, and some of the provisioning, at least from the perspective of client, is not very secure or something that we want to trust going forward. So just on this point, the PVD approach does allow taking any proxy that you've learned through one of these mechanisms and upgrading it into a proxy configuration that can now have new protocol types. So that is one touch point of a relationship. But I'm also curious to hear what people think, if there needs to be anything more said on that topic. All right, so that's all the content I have here. Hopefully the updates look like this is going in the right direction. We'd love to have more reviews. We have a GitHub that's linked from the document, so please file any issues there. And I'd like to ask the chairs if we could get this adopted, since we've seen good engagement from this group over the past couple meetings.
Thanks, Tommy. Yes, I think we've definitely seen some good support. I don't know if there are any questions. Otherwise, we would gladly use now the tool to at least have a show of hands for adoption and then confirm on the tool. But let me first ask if there are any questions.
Well, can you hear me?
Yes.
Yep.
Okay. I don't see the button to raise my hand.
Oh, not yet. It's. I was just asking if there was any discussion, but you will see it in a couple of seconds.
Okay. Does that mean you're asking for discussion on the motion, or just Q&A for the presentation?
Oh, well, now we started the show of hands.
Yeah. Well, I was asking if there were questions for Tommy, but seeing none, I'm asking now the question for show of hands to the group. It's not really a motion. Like, we don't carry motions here in IETF, but
It's a virtual hum.
it's a virtual hum, exactly. So, well, the question is up now. So, do you support adopting draft polling INTAREA proxy config PVD as 02 as working group document? And please do your virtual show of hands. So I'm going to leave it on for 10 more seconds. Okay, so now I think it's stable. So we have 27 that raise their hands for yes, 1 no, and 5 no opinion. So I think we have a pretty good support. Whoever said no, I don't know if they want to raise their concern.
I'd love to hear any concerns if people have them.
Okay, well, in any case, we will confirm on the mailing list, but so far so good. I think we have for adoption.
Thank you. Thank you. All right.
Thank
I
you.
think that's it then.
Thanks. All right. So next one is Bill.
Okay, hi, Bill Fenner from Arista Networks. I realized that I didn't make any background slides, so I'm just going to sit on the title slide for a little while. I've been so deep in this topic for that, I forgot that other people might not even know what the protocol is. So what is Probe? One of the motivations for Probe is looking at the status of the network in these deployments where a router might not have a unique IP address assigned to every interface. Or in fact, a router may not have a unique IP address in within the domain to be able to use ping to check on liveness. And so, so Probe has kind of 2 modes that you can run it in. In one mode, you're asking about a local interface on the router. So you can address a packet to the router and say, hey, router, how's your Ethernet 2 interface doing? Is it up? Does it have v4 and v6 addresses assigned to it? And another mode that you can run it in is called the remote mode, where you can, it's kind of a query of the ARP or neighbor discovery cache of the router. You're saying, hey, do you have this entry in your neighbor discovery cache, and what state is it in? Is it in delay or like failed or working, right? So for the one, you can kind of look at your own system and say, this is how I think it's working. And for the other, you say, this is a peer that I know that he has, and is he likely to be able to talk to his peer, a routing peer or whatever. So that's the basis of the protocol. It was published as RFC 8335, and I decided to implement it. And so I tried to understand it from the RFC, and then what I was observing kind of didn't match what I thought I was reading in the RFC. And so that's where we start getting into the details of what these packets are. These packets use the RFC 4884 extension mechanism for ICMP. And so that packet format has kind of a header and a checksum, and then arbitrary objects after that. And the request information is stored in one of these extension objects. You can ask for information about an IF index of the router, interface name, or you can specify an interface by address. And that's communicated in this extension data. And one of the clients that I found didn't fill in the extension header. And so it only worked against a responder that I found that doesn't check the extension checksum. So that was, I started collecting these observations and saying, gee, these are things that maybe should be clarified in the spec so that when people go to implement these things, everybody does it the same way. Another really interesting aspect of the spec was that they echo the data that they received, but the only place that the spec mentions echo is in the name of the ICMP type. The ICMP type is ICMP extended echo, but there's no place in the spec where it says copy the data from the received packet to the sent packet. And then there's another aspect of this RFC 4884 ICMP extension where that RFC says that the extension header is followed by one or more extension objects, and those objects are formatted in this way. And the two of the implementations just added extra information after it, just like the ping client does, some data to test if all the bytes are getting through. But my read of the spec said that that wasn't allowed. So, so that was what the responders did. Then we have clients. How did the clients behave? So as I mentioned, the extended checksum was an issue with both receivers and clients. Again, extra data, some of the clients said I should do that, and I said, no, you shouldn't. And then of course, there's relying on that extra data. The traditional ping program sticks a timestamp into the packet and relies on that being returned to it to measure the RTT. But again, the spec doesn't really talk about echo other than in the name. And then there's, it's one of these things where the option is supposed to be multiple of 4 bytes, but the interface name might not be a multiple of 4 bytes. So you add padding, and then, is the length of the interface name object that contains pad me plus 3 padding bytes, is that length 5 or length 8? And, that's something that turns out was being done differently by different clients. And then a final topic that came up as I was investigating this was how can a user interpret the result of his probe request? So, this is a nice client that prints out all the information that it got, right? And it prints it in a very familiar form. This is, basically how ping outputs its data. So is this good or bad, right? If this was a ping, the answer is this is good. But it turns out this hidden in there, there's active equals 0, IPv4 equals 0, IPv6 equals 0. It's like if you were expecting that this link was up, then this is a bad response. So that's kind of a UI issue, but it's something that's important to be able to make the tool usable for people. So kind of a wall of text of what's changed. This is in a section of the document, so we don't need to be desperate about it here, but basically I tried to cover each of those areas that that I thought the spec was lacking, and also to address the human readability aspect of the messages. I added a section to the appendix. It's already non-normative, but it talks about if you're going to print, if the response came with an error message, just print the error message. Don't print the rest of the fields, because the error means that the rest of the fields don't matter. And then, if you're querying a remote interface, don't print the fields that are relevant only to the local interface. That's just clutter in the UI, and that's going to confuse the user. The important part is the remote interface state. And then a suggestion to print, there are these 3 bits. Is the interface active? Does it have v4? And does it have v6? And the suggestion is kind of to, rather than say, I'm going to print out false, false, true, to make something nicer than that. Interface is not active, or interface is active and has v4 on it, rather than just saying v4 equals 0, v6 equals 1. So finally, here's a bunch of stuff that I've done. So I created a couple of Python tools using Scapy. One of them sends these probe requests, and the other one is intended to test a client, and it acts as a probe responder and just serves up all the possible responses that you can get. So you get interfaces not active, and you get interfaces active without v4, and you get interfaces active with v4. So, unlike a regular system where you would expect the response to be relatively stable, with this synthetic response generator, you get one of each response in sequence. And so this allows you to test a client without having to set up the test conditions on a neighboring router. A couple of pull requests to the TCP dump repository to be able to print out the contents of these packets. A fork of the IPUtils repo there was some previous work in a Juniper Summer of Code or something like that, a couple of people had submitted, and so I started with that and updated it. So that's a GitHub repo with a bunch of issues opened in it and a bunch of code available. And then the URL for this document, because it's being developed on GitHub. So what's next? In my mind, the only pending issue is what to do about author count limitation. There were 5 authors on the original RFC. I'm number 6. We'll figure it out. I really am just saying that because I don't want someone else to say, hey, there are 6 authors and you can't have that. although Jen,
Okay, thanks. You want to take
Jen-
questions now?
yeah, I'll take, I mean, Jen's in the queue, so.
I can wait if you have more slides.
I don't have more slides. I have 2 more bullets on this slide, but
So, well, just addressing that, I guess the authors is something that we can address down the road, right?
exactly.
Yeah, I
So-
just actually, yeah, I just put myself to the queue just to say thank you for finding all that's inconsistencies. As an author of the original one, co-author of the original RFC, right? Just thank you for fixing all those bugs. And I'm quite sure, yeah, we can talk about sorting out the author limits. So
Sure.
thank you.
Thanks. So the other 2 topics I had, well, interrupt testing was something that came up. You know, I wrote all this code, so if I got it wrong, then I'm testing with my stuff, and that's wrong too. So, you know, some more interrupt testing might be useful, especially since I'm trying to address issues that I found in various implementations. And then, of course, the usual working group adoption question. I know that this is the first time that this group has seen this document, but at the same time, it's an update to an existing spec, and all of the existing authors have liked the work. So it may be appropriate to ask the question.
Okay, thanks, Bill. So, yeah, that's very useful, like I think, and but indeed, it's the first time that we see the work, and well, it's pretty recent. So, let me ask a question. Since we have quite a bit of people remotely, I'm going to ask it on the tool. How many people have read this draft? Could you please raise your hand? And I'm going to wait a few seconds here to see. Okay, 10 more seconds. Okay, I think now it's stable. So we have 6 people raising hands, 15 no, and 2 no opinions. So as much as I think that this useful work, probably we need a few more eyes to read the document before calling for adoption.
Okay, great. I'll follow up on the list.
But yeah, if you don't mind sending a reminder on the list. I saw your original email, but probably now that we have seen the presentation,
Right now that
it's a good time to
awareness is raised,
Exactly.
maybe there will be more opportunity for discussion on the list. That's
Right.
great.
Okay, thank you.
Uh-oh.
Yes.
Oh, okay. Oops.
It's okay.
Okay, so this is a little bit in a similar vein to address problems that arise when you have a deployment where not every node has a unique IPv4 address, not every router in the system has a unique IPv4 address. And in fact, you may not have you may have repeated v4 addresses throughout a given domain. So what's the problem? We see customers, wanting to create deployments of routers without having an address assigned to every single interface. They want to conserve their v4 addresses for the servers that need them, and so we use v4 routes with v6 next hops in order to do routing based on using v6 addresses of neighbors instead of v4. And then, so in the easy to imagine scenario there, each router does have a global unique IPv4 address. So you say, oh, how do I address a router? You you know what its address is. But there's a kind of more extreme scenario here where the address shortage is so severe, or just the overhead of making allocations is problematic enough that maybe you have a network design where here's your spine and here's your leaf and whatever, and they each have an address. But then you take that design and you replicate it in another data center without changing the addresses. You know, you can do all your network management, et cetera, over IPv6. So that part doesn't matter. And within a data center, you can get a trace route that goes, you can identify, you know, leaf, spine, core, spine, leaf. And then you take that one step further and you just say, I don't have any IPv4 addresses. I'm just going to use this reserved address as the v4 address that I'm going to respond to traceroute with. And this output doesn't really tell you anything once you get down to that level of conservation of addresses. They're all the same address. So we do have RFC 5837, which uses, again, these RFC 4884 ICMP extensions to be able to tell you more information about an interface. But it's about interfaces. It's saying, here's the address of this interface, or the name, or the IF index. And it can tell you information about the incoming interface and the outgoing interface. But this doesn't really necessarily help you identify the router still. And the address it has to be the same address family as the packet that you're responding to. So you can't say, here's the v6 address of this interface. I did assign a global v6 address to this interface, and I will give you that information. So, that doesn't really fit the problem. Right. There may not be an address that you can put into the packet. And if from the central system, when you are looking up an address, when you get an address back, it requires another lookup to figure out what the node name is. So the proposal is to create another one of these RFC 4884 based ICMP extension mechanisms, which can return you an IP address. There's very hand-wavy words here of appropriate scope in order to identify the system, or a node name. So the most obvious value of appropriate scope is globally unique. That's definitely appropriate. With the thinking that this is going to be deployed within a single domain, it may be reasonable to return addresses that are only useful within that domain anyway. But this allows you to just send back a text string. Here's my node name. What kind of workarounds might we have in the existing system? Well, one is we can violate the must in 5837 and include an IPv6 address when we're replying to an IPv4 packet. You know, that maybe, but that then relies on a router having globally unique v6 addresses. And with this trend that we're seeing, we don't necessarily want to rely on that. The other thing we can do, and we've gotten this request to do this, is to play fast and loose with the words other human meaningful name. And hey, you know, the interface is called 25GigE1013 at hostname, right? That's a human meaningful name. And, you know, the problem I see with that is length limitation and also formatting. Like, what if someone else uses a slash? What are vendors going to do putting random data in there? So that's all about that. And obviously this is kind of brand new stuff, so I'm just here to gauge interest. I've showed it to customers and they've said, ooh, that sounds cool, but I want to see what people think here. Hey, Bob.
Hi, Bob Hinded. Have you looked at node, the IPv6 node information query? Because there's maybe some things in here that are sort of similar.
Um, I've,
I don't remember the RFC number.
yeah, a million years ago, I have looked at node information query,
Okay.
but it didn't. Yeah, I'll look again.
I mean, there might be something else to build on,
yeah,
perhaps.
right. Use it as a building block for the types of information to return or
Yeah.
the packet formats or something. Thanks.
Darren Dukes. Yeah, I've got customers with similar requirements to what you're getting here, where they need more information than what they're getting in their ICMP message, particularly on the V4 side, where they want actual V6 information from other nodes.
Okay.
So yeah, I think there's definitely value in investigating this more. Love to help.
Okay, great. So I looked at the IANA registry, and it turns out it's first come, first serve. So if no one tells me this is a horrible idea, I'm going to go apply for a code point after this meeting.
Okay.
Okay. There, I mean, it's like organization specific. I could do that, but you can, I mean, look, if I get number 5 out of this registry and then everybody tells me that it's terrible and we don't adopt it, I'll give it back. But, okay, thanks.
Thanks, Bill. All right, so similar to the other one, please continue discussion on the mailing list, but looking good so far. Okay, next, yes. Do you want to share, would you like to use the share slides? It works better than the screen. Lynn? If that's okay. On the bottom of your Meetical tool next to the hand, you have share slides. So you should see your slides there. Or I can share if you prefer. But it's better if you do it. Or I think I can share and pass you the control. Lynn Head, can you speak or we cannot hear you? Can you click on the unmute audio below on your screen? We still don't hear you. We can see you, but we cannot hear you. Yeah, it could be that you have a different mic when you connect it to Meetical. Because I can see your audio is on, but we don't hear you. So probably you have a different mic. Okay, yeah. Can you share again? Can you ask again? Once again, please. Sorry. Oh. Sorry. Okay, yeah, sorry. If you look at the chat, Lorenzo Mineiro is telling you that you need to click your avatar in the bottom screen so that you can check your selection again. So in the bottom screen, you click on your picture or avatar, and then you should be able to reconfirm your preferences to check which mic you are connecting on, because we don't get any audio from you. Okay, so he's going to reconnect. Since this is the last presentation, we're going to hold for a couple of minutes. Exactly. Okay.
Hello, can you hear me?
Yes, we can hear you.
Thank you. I'm sorry for the inconvenience.
No worries. Do you want to share slides on the bottom next to the hand, please?
Can you share this slide for me? I don't
Okay.
want to share my screen.
Okay.
Okay. Hello, everyone. My name is Lin He from Tsinghua University, and today I'm going to introduce our draft, a savvy solution for wireless LAN. My presentation is divided into 3 parts. First, let's go to the background. Source address spoofing has led to the spread of network attacks and other security incidents, and has become one of the most important security risks of the current internet. As shown in the figure, if host A sends a packet to C with source address E, then there is no problem. However, host A can spoof the source address of the packet it wants to send to C to be B, then making C think that B has sent the packet to it. So in this case, there will be a problem. For this issue, the IETF established the Savvy Working Group in July 2008 to address this issue. Its goal is to ensure that hosts attached to the same in this slide. Its goal is to ensure that hosts attached to the same IP link cannot spoof each other's IP addresses without disrupting legitimate traffic. Next, please. To enable network operators to deploy fine-grained IP source address validation without dependency on supportive functionality on hosts, the Savvy method was designed to purely network-based. A Savvy solution enforces the host's use of legitimate IP source addresses according to the following 3-step model. First, identify which IP source addresses are legitimate for a host based on the monitoring packets exchanged by the host. Second, bind a legitimate IP source address to a link layer property of the host's network attachment. This property we call binding anchor must be verifiable in every packet and that the host sends, and then must be harder to spoof than the host IP source address itself. Third, enforce that the IP source address in the packets match the binding anchors to which they were bound. Next, please. There are various binding anchors that can be used. For example, IEEE extended unique identifier, switch ports, and so on. The various binding anchors differ significantly in the security they provide. For example, IEEE extended unique identifier failed to render a secure binding anchor because they can be spoofed with little effort. Currently, the commonly used ones are switch ports. The Savvy Working Group has developed RFCs for a variety of scenarios, including DHCP, Slack, and Send. Next, please. So how about in wireless LANs? Switch ports are commonly used as binding anchors in wired networks. However, there is a lack of naturally available binding anchors for wireless LANs scenarios. So in addition, wireless LANs suffer from the problem of user mobility. When a user moves to a new access point, there is a lack of appropriate binding entries for source address validation. So therefore, we need a solution for wireless LANs. Next, please. Next, I will introduce the Savvy WLAN solution. Next, please. This is a high-level overview of Savvy WLANs. Savvy devices, in this case, are APs, access points, and access controllers. They first listen for address assignments, establish bindings, and then validate the source address of the packets. The binding entries are also synchronized and confirmed between APs and ACs, and between ACs and ACs, taking into account that the user may be mobile. Next, please. We use MAC addresses as binding anchors in Savvy wireless LAN, but they must be secured using mechanisms such as 802.11i or other mechanisms. If the MAC address is unprotected, an attacker can spoof the source MAC address to pass validation successfully. Next, please. We have designed two data structures. The first one is IP MAC mapping table, and the second one is MAC IP mapping table. The IP MAC mapping table maps an IP address to a MAC address, and it is used in the control process. Notice that an IP address can have only one corresponding MAC address. Different IP addresses can be mapped to the same MAC address. Second, MAC IP mapping table maps a MAC address to an IP address. It is used for filtering. Note that a MAC address can have multiple corresponding IP addresses. The MAC and IP mapping table and the IP MAC mapping table can be maintained separately on different devices. For example, access points or access controllers. A synchronization mechanism must be used between these two tables to ensure the consistency of the bindings. Next, please. We consider three scenarios for binding creation. The first one is static. All the static IP MAC address pairs are configured into the IP MAC mapping table with the mechanism enabled. Second, DHCP. The Savvy device snoops the DHCP address assignment process between the attached host and the DHCP server. For Slack, the Savvy device snoops duplicate address detection procedure or address resolution procedure between attached hosts and neighbors. Next, please. We also consider 3 kinds of events that will trigger banding clearing. The first one is a host leaves explicitly this access point. All entries in the MAC IP mapping table associated with this MAC addresses must be cleared. Second, a DHCP release message is received from the owner of the corresponding IP address. This IP entry in the IP MAC mapping table and the corresponding entries in the MAC IP mapping tables must be cleared. Third, a timeout message of the AC's client idle time is received. All entries in the MAC IP mapping table related to the MAC address must be cleared. Next, please.
Just a quick question for you, since you have some more slides. Are you going to take questions in the middle or at the end?
Both are okay. Both is okay.
Okay, so we have Lorenzo in the queue. I don't know if your question pertains to this at the end. Okay, thanks. So please continue.
Okay. Next, please. This slide shows the process of performing secure source address validation. First, we extract the IP source address and MAC address from the frame. And then we will look at the MAC address in the IP MAC mapping table, in the MAC IP mapping table, and check if the MAC IP pair exists. If it exists, the Savvy device will forward the packet. If not, then we will look at the IP address in the IP MAC mapping table and check if the IP address exists. If not, we will drop the packet. If yes, we will check the MAC address in the entry is the same as in the frame. If so, then we will forward the packet. Otherwise, we will drop the packet. Next, please. This slide shows the mobility solution. When a user roams from AP1 to AP2, as in the figure, AP2 requests the IP addresses corresponding to MAC1 from AC2. If AC2 needs to request banding entries from the ACs, the synchronization between ACs occurs. The result is then returned by AC2 to AP2. The CapWrap extension is used to synchronize banding entries between APs and ACs, while the method of synchronization between ACs can be determined independently. Next, please. We also consider 2 deployment scenarios. The first one is centralized wireless LAN, and the second one is autonomous wireless LAN. Next, please. For the first scenario, centralized wireless LAN, we consider 2 cases. The first one is AP filtering. In this case, AC maintains IP MAC mapping table, and AP maintains MAC IP mapping table and perform address snooping. Next, please. The second one is AC filtering. AC maintains both MAC IP and IP MAC mapping tables and performs both address snooping and packet filtering. All the packets will be forwarded to the AC firstly. Next, please. The second scenario is autonomous wireless LAN. In this case, AP conducts filtering. In this case, FAT AP maintains both MAC IP and IP MAC mapping tables and performs both address snooping and packet filtering. Next, please. Since Savvy Wireless LAN uses MAC addresses as binding anchors, we also consider the effect of MAC address randomization. In wireless LAN, random MAC addresses are mainly used for discovering wireless networks and accessing networks and communication. For wireless network discovery, a host uses proper request frames to discover wireless networks. This does not affect the establishment of Savvy binding anchors. Second case is network access and communication. Random MAC addresses are used to send and receive packets. In 802.11i wireless networks, the key used for communication is tied to the MAC address. And the random MAC address does not change during communication. Usually in the same wireless network, the random MAC address does not change when you re-access the wireless network to ensure roaming experience. If the MAC address changes, the access needs to be rechecked. In summary, the anchor of Savvy binding is stable during one access, and the Savvy function will work well. Next, please. Next steps. Next, please. We're here to solicit comments, and we will refine the draft according to the guys' comments. And the authors would like to thank Bob Hinden, Eric Klein, Qinggen Wu, Xiangqin Chang, Nanzhi Su, and Lu Huang for their valuable comments. Thank you. Any comments?
Yes, thanks. We have people in the queue, so let's start with Lorenzo.
Yeah, so I noticed that the draft mentions that Slack addresses or bindings are populated by snooping dad. That's an approach that people often think of first, but it doesn't work very well because dad is only one packet at the beginning of the exchange, and it can be frequently dropped. Additionally, if you just snoop dad, you have no way of expiring the address because you don't know how long it lasts and how long the host is there for. So snooping dad is not a workable way of doing this. This is, however, documented in 6620 FCFS Savvy. So maybe you should just use that, which is already an RFC.
Okay, thank you.
Yeah, I mean, another thing that we might want to mention is that there's a draft in DHC, which is, I guess on its way to ISG right now, where there is a DHCv6 address registration packet. You could consider using that to build state as well. That means you only have to look at one protocol, but FCF, in any case, you'll have to figure out something out for Slack.
Oh, thanks. We will consider your comments, and we will refine the draft in the next version. Thank you.
Okay, thanks. Next, I put myself in the queue. I have a question. No, Chair had. So I'm moving to slide 22, just because you're talking about the MAC address randomization and the fact that the random MAC address does not change when you re-access the wireless network. I think that it's not necessarily the case all the time. Besides in 802.11, right now there are multiple active discussions in 802.11 BH and BI regarding how to randomize the MAC address, how to synchronize that between different networks or even between different clients. So just a word of advice, a lot of these assumptions are currently being changed in 802.11 regarding the use of random MAC addresses. So you may want to consider that too.
Okay, thanks. We will consider this issue. Okay.
Yen?
Jen Lenkova, it's not like probably problem, like not directly related to your draft. Maybe it's kind of problem with original DHCP Savvy draft, but DHCP would allow, a DHCP v6 can allow you to get a prefix delegated /64, whatever, right? It could be a lot of addresses. So I assume that any Savvy solution should also snoop DHCP v6 prefix delegation exchanges and allow all those addresses. So you might want to put not just IP addresses, but the prefixes for IPv6 into your table, because otherwise, like, prefix delegation would not work for those devices.
Okay, thank you. We ignore this issue, and we will consider the prefix issue in the next version. Thanks.
So
Thanks.
Eric Vink,
Eric?
to be honest, I didn't read the draft, but I wonder what's the difference with RFC 6620 and the others that were already doing something very, very similar. And to be honest, right, I work for Cisco, and now, don't want to make an advertisement, but this technique has been used for more than 10 years now. If I understood your proposal correctly, maybe it goes beyond, but it would be nice to explain what you are going beyond the existing solutions.
Okay.
Thank you. Stuart?
This is Stuart Cheshire from Apple. And I think I may be saying something similar to what Eric said, but from a different point of view. It wasn't clear to me from the presentation what needs to be standardized by the IETF. This sounds like a reasonable product feature suggestion, in which case some access point maker can just ship this feature, snoop on the neighbor discovery, and enforce this security. IETF standardization is needed when different devices need to communicate. And I didn't see anything here of a request for Android should change to do this, or iOS should change to do this, or Windows should change to do this. It seems like this draft has been around since April 2011, so it's 13 years old now. And it seems like this would be a fine thing for a vendor to ship. I'm just not understanding what the request of the IETF is for this.
Currently, the Savvy solutions RFCs standardized in the IETF does not address this the issue in the wireless LANs. So we came here to trying to standardize this draft. And as for the as the Savvy working group has been concluded, so we come here to trying to standardize this draft.
I'll let Lorenzo speak next, but if a vendor wants to ship a product, they don't need IETF permission to do that, right? I don't think the Savvy working group being closed is a problem for vendors that want to ship products.
Thanks.
Lorenzo Colletti. Yeah, I mean, I think this kind of is solved in existing Savvy solutions. In particular, you know, if you take DHCP6 Savvy for DHCP6 and FCFS Savvy for Slack, or if you just use FCFS Savvy for everything, that basically uses the MAC address as the binding anchor, which is basically what you're doing here. I'm not sure that this is actually sort of not solved, right? And I'm not sure it's different because yes, this draft mentions that if you have 802.11i, then the MAC address is secure, but the FCFS Savvy already uses the MAC address as the binding anchor, so I think that's the same.
In existing standardized RFCs, the MAC address, although the MAC address are used in the binding anchor, but they also they are combined with used with switch ports. So more use case, they are more used in the wired networks. So we consider this issue in the wireless networks, wireless LANs. We can talk about this issue in the mailing list.
Okay. All right. Thank you very much, Lynn.
Thank you.
I see no one else in the queue. Any other questions or business? All right. So, seeing none, thank you very much, everyone. Thanks, Josh, for the notes.
Hold on. I just raised my hand.
Yes, please go ahead.
Just in the category of other business. I just posted a email to the INTAREA list. Just this kind of goes in parallel to Tommy's PVD stuff. I'm working on a new draft of WPAD to modernize it and support new config file formats like PVD. So I sent the mail to the INTAREA list for folks who are interested in participating or discussing kind of the new scenarios and discovery mechanisms that have become used in the last 30 years. I'm seeking your feedback. So I'm going to post the link to that email in the chat.
Okay. Yes, so please put the email on the chat, and then you can refer back to on the mailing list.
Okay.
All right. So I think that's it. You're going to get back a few more minutes before the plenary. So thanks everyone for attending, and see you next time.
Okay. Is there anything else I need to do for the minutes, or just leave it in the head doc? Should I repeat?